Hello everyone and welcome to this fourth and final Into Power webinar. Today we're talking about drones. More specifically, we'll make a stop at 3 unique North Sea region locations to test your offshore drone technology. My name is Van Nachterhalen and I work on all drone-related topics at the Regional Development Agency of West-Vlaanderen, Belgium, where we are developing several drone hubs for testing and innovation alongside the Belgian coastline. Before we start, I would like to go over some practical issues with you. First of all, this webinar is being recorded, so it will be possible to see a replay afterwards. Secondly, please make notice of the fact that this webinar is viewed best with Google Chrome. If someone should be experiencing any problems, first make sure you switch to the Google Chrome browser if you haven't done so already. Also, on the right side of your screen, you can see a chat box. In here, you can ask all your questions for our experts. Celine, our behind-the-scenes moderator, can help you if you have any technical questions or problems. Now, since you all know who I am, it's only fair for me to know who you are. In order to do so, I will launch a poll, which you should be able to see on your screen right now if you scroll down a little bit. Let me know by clicking the answer that applies to you. Thank you. So we can now see the answers coming in. So a greater percentage for research and development right now. I'll wait a few more seconds. Okay. I think most of the people here are in research and development, so welcome and welcome to all the others as well. In a few moments, the drone test facility operators will take you through their test facility, share their expertise and answer all your questions. But before they do so, please note that Into Power project has a dedicated webpage on test facilities in the offshore wind sector, among others also on test facilities related to drones. The link to that page will be shown at the end of this webinar. The use of drones and unmanned aircraft systems is expanding by businesses and consumers. In response to this expanding market, there is an increasingly complex regulatory environment around drone certification, with national and international aviation and product safety regulations being developed to cover these products. A drone test ensures your product is compliant with all relevant UAS and drone legislation in your target market. Testing and certification can minimize the risk of non-compliance and product liability. Needless to say that weather conditions, for instance, are of the greatest importance in relation to UAV testing, which seamlessly brings me to the second poll. Just one instant. So you should be able to see the second poll now. So I want to know who of the attendees have ever experienced issues in respect to performance, reliability, or safety in the following conditions. So we're talking about rain, wind gusts, salty environments, low temperatures, icing, extreme hot conditions, or no experience at all. So I can see the results coming in right now. And I see that most of the attendees have no experience with harsh conditions, and more than 30% have experience with rain, wind gusts, and salty environments. Okay, thank you. And before we go to our first speaker, there is one little thing I would like to know. A third poll, which asks you if you ever have tested drones in a test facility. to understand the climatic conditions on the drone. So most people have not tested. So this webinar will be interesting for a lot of you who have no experience. It will be completely new maybe. So without further ado, I shall give a go to our first speaker, which is Mr. Pieter-Jan Jordaens, Program Manager, Onshore and Offshore Wind Energy Industry at OWI-Lab. Pieter-Jan, good morning.
Good morning. Thank you, Sven, for the introduction, indeed. My name is Pieter-Jan Jordaens. I'm working as a program manager onshore and offshore wind energy at Series OWI-Lab. And I will be presenting the topic of environmental testing mainly. And I will focus on what I would call 2 environmental torture facilities that can test drones, either airborne drones, but also underwater and surface water drones, to the extremes with respect to environmental loads. So if we have a look at an offshore wind farm to date, I think we can fairly say it's one of the largest rotating machine in the world, which needs to operate in very harsh climatic conditions, meaning the Baltic Sea or the North Sea conditions are quite harsh, as you know. And in order to do so, also the machines themselves are heavily tested for all kinds of conditions. And with the current trend of introducing robotics or in general drones into these wind farms, this also comes with certain needs with respect to the environmental loads. So gusts, temperature changes, humidity, rain, maybe in some cases even icing conditions in wintertime need to be taken into account. And certainly if you think about some new trends, and there have been some publications about using or housing drones as an autonomous system in wind farms. Also, this equipment, of course, needs to operate in all kinds of conditions, taking into account corrosion as a durability effect, but also, of course, you want these to work in all conditions when it's there, because if you need to maintain that or need to repair that, that's quite costly, and then the advantage of a drone is gone, of course. On the other hand, another trend, the surface drones or the underwater drones for surveys and inspection are also coming up. And also there we see some environmental loads or requirements that are important to take into account for reliable operations, meaning water ingress, shocks, vibrations, corrosion, again, splash icing in wintertime, which can all pose additional challenges with respect to the machine's performance, reliability, and also the durability on the long term. Now, what we don't want and what operators don't like are these kind of conditions. Failing drones in all kind of seasons or operations. The malfunctioning of a drone is what we don't want, and we want to make sure by testing and, of course, also advanced designs, failure mode and cause analysis, etc., we want to not have these kind of scenarios where environmental loads, and there are some examples here, icing, mechanical dysfunction due to gusts, battery life that has been decreased due to certain conditions, but also marine growth as an environmental load, as you can see on the right and below. Those can all impact the performance and the reliability of systems. So with a new technology trend also comes a new learning curve, and you could compare this with an iceberg. Of course, we want to understand by testing, and this is the value of advanced testing and these testing facilities, to understand what is below the surface with respect to risks. So there are the known knowns, and of course you want to validate them in a testing facility, but we also want to know the known unknowns, and sometimes we also detect unknown unknowns in these testing campaigns, which are of course very valuable if you want to understand what are the infant mortality failures, what are the constant failures, and what are the durability or the fatigue failures, in order to come up with bathtub curves, as we call them, and in respect to the reliability curves of these new machines. And I think fairly we can say there is still some learning curves in understanding all these conditions, specifically for those new markets of offshore wind energy and others. To give you an example of a known unknown, if we look at search and rescue helicopters that need to operate in marine environments, so at the North Sea, for example, also there we see that in some winter conditions, because of the humidity and the cloud formations that you have near the sea, specific icing conditions can occur in wintertime. And this is known in the aerospace industry, but is probably also further to be understood in the offshore wind energy, specifically if we talk about the Baltic environments, because at some point we also want to operate these machines in winter conditions as well. And how can we test them, or how can we ensure reliable drone operations? Of course, testing already gives an insight in the risks and how a certain drone can perform in all kind of harsh conditions. And we're focusing on this environmental testing, and you can see a picture here about how this will look like and how this looks like in a combined setup, which I will explain. We, as a technology center in Belgium, our mission is to support companies in innovation projects, and to do so, we have certain test services, which I will explain. It's important to say that with respect to the onshore and the offshore wind energy market, we are combining our forces with the University of Brussels and the University of Ghent. And 10 years ago, we have been constructing a unique facility, which will be explained. And recently, we also have access to another one, which will also be shown. And the goal of our expertise and the facilities is to support you and give you that leading and competitive advantage towards the others, of course. I think having access to unique testing facilities worldwide is, of course, a merit, as you can understand. The two facilities that I will highlight with respect to environmental testing are, on one hand, the climate chamber test facility, on the other hand, a large wave tank testing facility, which is recently being constructed. And those torture chambers, on one hand, focus on the climatic conditions, meaning temperature changes, icing conditions, humidity, corrosion effects. On the other hand, the large wave tank test facility, which is owned by KU Leuven, University of Ghent, and the government, is more focusing on the mechanical environmental loads, meaning shocks, vibrations, and of course also water ingress at some point can be tested there. If we look at the type of drones, I think we can say that the climatic test facility is more applicable to the airborne drones and the autonomous missiles, for example, in testing battery life or battery durations in certain conditions, as an example, and that the wave tank facility is more applicable into shocks and vibration testing of the autonomous vessels and offshore glider underwater drone market, I would say. What is environmental testing? In short, we have natural environmental conditions that can impact the performance and reliability of a machine, and there's the second hand or the secondary environment, meaning the induced environment. So the natural environment, that can be icing, temperature changes, as an example, rain, hail, etc. The induced are more related, for example, if you have a ship and you have an engine operating there, of course, the vibrations of that ship can also introduce certain additional shocks or vibrations or accelerations towards other equipment. So that's an example of a secondary environmental load. So it's those loads that we want to reproduce and see what that effect is causing with respect to the performance and the reliability of a system, typically an electromechanical system in our case. There is not so much known actually or publicly shared about the relationship of environmental conditions and the failures that are initiated by that. There are some advanced publications with respect to the aerospace industry, for example, and huge aircraft is one of them, as an example, where they investigated aircraft misfunctioning or failures and even crashes, and the relation to environmental conditions. And in many cases, temperature changes or temperature effects are in the top three, apart from vibration effects and humidity. I think also for other applications, certainly in the offshore environment, it's important to take those three conditions also into account. How can we test those conditions? So one of the torture chambers is the large climatic test chambers, where we can change temperatures from -60 to +60. We can do thermal cycling tests in an accelerated way. We have humidity conditions up to 95% relative humidity, infrared heat, and nowadays we're also adding icing into this facility. And we have been starting this facility mainly in the wind power market, in testing electromechanical equipment like large gearboxes, transformers, gradually also shifted to other industries. And I can fairly say that, of course, in many cases, we are validating the known knowns. Sometimes we focus indeed also on the unknown unknowns, but we have also had examples in which we have detected failures that were not foreseen. Also in the wind energy application, pumps or valves, small equipment that fails and has a big impact into the full system and the performance of that. So it's very important, I can say, to also test your equipment if you need to operate in a remote condition, and if the requirements pose a high reliability and a high performance, or a mission critical operation, for example, when you operate drones. We're currently expanding the lab. We're adding an icing test facility, as you can see here, or an icing test bench, as you can see here in this picture. And recently we have been starting in commissioning this rain spray and ice spray test setup, because if we are not going into the extreme low temperatures, of course, we can also use this as a rain spray test array, and we're also experimenting with this one at the moment. The icing test bench is actually supported by a European project focusing on the developments and testing of nano-based coatings. It's a project called Newskin, and there are 12 facilities in Europe which are being upgraded as we speak to cope with the advanced testing of nano-based coatings. Now, why is this important towards the drone industry? Of course, you also want to have solutions. If you need to fly in wintertime in a fog environment or a cloud, you also want to have a solution in place. And so we also want to focus on what kind of solutions are working in these conditions, and what are the new developments with respect to nano-based coatings, where we think there are some new advancements that could benefit the drone industry, specifically the airborne drone industry. An example here of the rain spray array as we are testing it, and of course this can be then used to fly around the climate chamber, and in the same conditions also change temperatures, for example, and humidity levels. An example of how the icing test bench looks like. And our idea is to combine the climate chamber now with this ice and rain setup together with a wind array. And this will be done in the coming weeks. We will also have a wind array to also have some kind of a wind load to the drone. And in that way, we can, of course, also simulate or experiment with what will the battery life be like, what is the condition or the performance under certain climatic icing and wind load conditions. So this is something which is coming up the coming weeks. And we see this as a unique capability to test also the offshore environment. For example, a wind speed or wind turbulences, because we can also simulate some turbulences with a specific wind array that we cope with, rain, and the other conditions, as I said before. And for us, a focus R&D point will be the icing on the drone. So one example here is the icing on a propeller. As part of a Flemish-supported collective R&D project called Fighting Icing, we're focusing on this condition, and we're also looking into the solutions again. So we have been purchasing more than 15 solutions, meaning coatings, and we made a available technology report, and we see there's different type of coatings with different performances and reliability. So all these types of coatings that are on the market are being purchased now. We're going to start in benchmark testing those, also on the drone as an example, but also on a wind turbine blade as a second application. And we're going to test and report about the functioning of them. So I think this is an interesting project in which Flemish companies can join for free, as it's a collective project supported by FLYO. To finalize, the second facility is more focusing on the mechanical environmental loads, meaning shocks and vibrations. And our partner in OWI-Lab, the University of Ghent, has access to this large wave tank, which is more than 25 meters by 25 meters large. It can be used either to test waves, but also a combination of waves and currents. And this makes it an interesting facility to focus on these autonomous vessels and underwater gliders or underwater drones with respect to, for example, the conditions in stormy environment and the autonomy of the battery as an example. More importantly, we recently have been supporting the University of Ghent in the application of a new motion tracking sensor or equipment. And the Qualisys AB, which is a 6 degrees motion tracking measurement equipment, has been granted and will be installed in this wave tank. And it can measure these 6 degrees of vibrations underwater and above water. So it means we can track the motions and the behavior in certain conditions in a very accurate way for validation testing as an example. So this is the end of my lecture or presentation. Then I still have a quiz for you and something to win. So we grant access of 1 free testing day in our climatic torture chamber. And as I said before, there is not so much known about the effects of environmental loads. Huge aircraft have done a study, and actually you might know this company because the CEO, Howard Hughes, has been presented in a blockbuster movie, a famous blockbuster movie, not so long ago, I must say. And those who can send me the name of that actor in this movie, and that can also provide me in your interest in why you want to have this free testing day and the company presentation or a brochure, we will make a small lottery of those applications coming in and grant 1 day of free access. So please mail me with your answer, and we will be in touch soon to showcase who is the winner of this small contest. So this is the end of my presentation. I'm open to any questions now.
Okay, thank you very much, Peter-Jan, for your presentation and sharing your torturing methods with us and giving the viewers the possibility to win at some time in your torture chamber. We have some questions for you. Bart wants to know if you can accelerate conditions and how fast can you change these conditions, for example, temperatures in the chamber?
Yes, so we can go from the Arctic cold, meaning -60 to +60, to the desert conditions in 1.5 hours. So we can cycle the temperatures, and that means that, for example, for electronics, there's a lot of focus on highly accelerated lifetime testing. So we, in some way, we can indeed accelerate the lifetime and also fluctuate temperatures in a very fast time. That also means that we can, with respect to the testing days, we can, let's say, either try to simulate the lifetime of an equipment in a very short time, or in some cases, of course, we can also reduce the testing time if it's only validation testing, because the speed of cooling and heating goes quite rapidly.
Okay, thank you very much. And another viewer wants to know if there's a possibility to perform corrosion tests.
So typically, corrosion tests are done in a small corrosion chamber, much smaller. But we have seen and we have been doing tests for the offshore oil and gas industry, in which actually after a while of testing, also corrosion effects come into life. Meaning, if we do humidity testing combined with temperatures, and specifically if it's metal equipment, we also see that at some point after 1 week or 2 weeks, we can already see some corrosion effects. But if we want to accelerate corrosion testing, then we would suggest to take or use a specific corrosion test chamber or a salt spray chamber, which we also have access to, but on a smaller level.
Okay, thank you very much, Peter-Jan. For our second speaker, we are going live to the Netherlands. Hello, Mr. Egbert Sweerts, business developer and Board of Advisory at Dronehub Groningen Airport Eelde. How are you?
Good morning, Sven. I'm good. How are you?
I'm fine, thank you. Okay, you can start your presentation, Mr. Sweets.
Thank you very much, Sven.
Just a second. This should be the one.
Let's develop drone business together. My name is Egbert Swierts and I'm a business developer at Dronehub Groningen Airport Eelde. Dronehub is located at Groningen Airport Eelde and is a perfect location for testing unmanned aviation in the real world. For instance, for development of technologies in the offshore wind industry. We have specific focus on the integration within manned aviation, also called Airspace. The core business of Dronehub Groningen Airport Eelde is collecting and sharing knowledge, bringing networks together, and giving support to innovative drone projects, especially within the north of the Netherlands. Groningen Airport Eelde is the only international airport in the Netherlands who has governed exemptions to allow drones experiments. With these activities, we hope to stimulate and accelerate drone innovations. With final outcome, the introduction of new products and services and an overall acceptance of society. A short selection of our projects are airport runway inspections, testing medical deliveries, mapping dock occupation, testing 5G connectivity for precision agriculture, and flying drones on hydrogen fuels. To give you a final summary, Groningen Airport Eelde is the only international airport in the Netherlands where drones are allowed. The wide open space in the north of the Netherlands is perfectly for testing unmanned aviation. Dronehub has an extensive experience in flying drones within airports and harbored environments. The airport is a controlled airspace, so not accessible for sudden intruders. The Dronehub team welcomes you and supports you in any way we can. I would like to give the word to Jan Wiersma, partner at Dronehub, who will give you some more insights on offshore wind inspections.
Yes, thank you, Egbert. I'm going to open my slide. Yes, my name is Jan Wiersma from the company Vliegend.nl, founded in the Netherlands by me, and I'm the owner right now. We are a system integrator and have experience with drone activities in multiple environments, also in offshore. And I'm going to share some experience we have with windmill inspection offshore in the North Sea. Our company is busy with consultancy, engineering, system integration, and training. offshore inspections with a drone. Of course, we have a lot of advantages of using drones. We expect much higher efficiency if we can cope with the challenges we also have. A few of them are high wind speeds, wind gusts, humidity. Also, we have, if we use a vessel for takeoff and landing with a drone, we have the possible compass failure of the drone. We have turbulence during takeoff and landing. And of course, we have the challenge of giving good quality by the data we acquire. We want to see anything which is out of the normal. So we want to see damages, defects, or delamination. And we want to have an efficient processing of those data and images. Yes. So we, of course, we have solutions for that. We have high resolution cameras. If we use medium format cameras with 100 megapixels from phase 1, for instance, and we can be on a safe distance of the wind turbines and still acquire the right resolution. We have a drone which is coping with high winds, industrial grade multi-rotor or helicopters. And we can prepare a vessel so we can have a safe landing spot for the drone and a safe takeoff location for the drone. If the drone is using a compass for navigation, we can make a construction for that. And we use artificial intelligence for processing of the images so that we can automatically detect defects on the turbines. And the future of drone systems offshore is in autonomous systems, maybe from Groningen Airport Eelde, or the shore, or maybe from the windmill park offshore. This was my experience. Thank you for your attention.
Okay, thank you very much, gentlemen. There are 2 questions in our chat box. Wim wants to know, in addition to the offshore wind and wind issues and integration, is it possible to test in real offshore conditions?
Yes. The north of the Netherlands is located right to the North Sea, to the shore. So from that location in the Eemshaven, we are very good equipped to do actual offshore testing.
Okay, that's clear. And Victor wants to know if there are any indoor facilities on the airport where drone technology can be tested. So indoor facilities.
Yes, we work closely with a very large facility right next door. It's called Royal Flora Holland, and they provide us indoor location to do testing.
Okay, thank you very much, Egbert and Jan. For our last speaker, we are going to Denmark. How are you, Mr. Hartpol Peterson, Head of Business Development at Odense Robotics? Good morning.
Good morning, Sven. Thank you. Yes, it's a snowy day here in Denmark today for the first time in a long time. Not so cold as it's been the last couple of days. Let's go ahead and
start the presentation.
Okay, yeah, you'll start it. Thanks. So I'm representing the UAS Denmark Test Center facility, and it's our national test center in Denmark. It gives you the possibility of testing your drone in unique BVLOS airspace. I will show you something about the airspace that we have in the test center, and I'll also tell you a little bit about the newest projects and companies that are around these days, and of course also a little bit about the project U-Space Fyn that is running right now. The Danish National UAS Test Center is located at the Hans Christian Andersen Airport, and we have 4 partners in total here. So apart from the airport, then it's also the Southern University of Denmark, who is a partner, and that's the drone center that is located right next to the airport. And then it's the municipalities of Funen and the business region Funen. And we do this in a very strong cooperation with the Odense Robotics, which is Denmark's national cluster for robots, automation, and drones. Now, the test center is located right in the heart of Denmark, in Odense, just outside Odense, in the airport, Hans Christian Andersen Airport, as I said. And just to give you an idea where that is approximately 2 hours drive from the north of Germany, from Flensburg, or it's 2 hours drive from Copenhagen, or it's 2 hours drive from Aarhus. So that gives you a pretty good idea where it is, I guess, if you know just a little bit about Denmark, or at least you can then locate it. What Hans Christian Andersen Airport is that is a, well, right now, not these days due to the COVID-19 restrictions, but normally it's a full functional airport where you have everything around. You have the security, you have the fence, and you have the AFIS. So you have the tower that looks after whatever is going on. And still, it's possible to operate the smallest UAS up to the very large UAS, which require a paved runway for takeoff and landing, because we have the infrastructure of an airport. And how do we manage that? It's simply because we have the possibility of making it a segregated airspace where you are allowed to only use the drones and operate the drones for a certain amount of time. If you look at the airspace, that is defined by the authorities. And if you look at how large is the airspace, then it's 867 square kilometers in all that we can use for the drones. Of course, we do not always use all of the airspace, but that's a possibility. And here, a more close look to the airspace. It's so that it's into 3 separate test zones, and there's a test area 1, 2, and 3, of course, where the number 1 is close to the airport, and number 3 is on the actual coastline. So it's a possibility to make a takeoff right next to the coastline and go oversea immediately. We do have both BVLOS and VLOS flights here, and we have 2 times a day. We have no time hours. So there's a notice for airmen that there's now drones in this area, and you cannot just fly next to it. So that gives us a possibility to operate tests for a couple of hours each day. And if necessary, we can close for a whole day if it's a very long and a strong test where we have to go very far. So altogether here, it's a possibility to go to the height of 3,000 feet. You can go up to 30 kilometers away from the airport. And as I said, it's 867 square kilometers in total in this area. We do also have the possibility of making a longer flight. That is not on the map here, but on a very special circumstances, we have the possibility to go through a corridor over the sea to very close to North Zealand and back again. But that is for very special testing, and of course, then we have to make sure that everything is okay. So what is this about then? Basically, it's about making the possibility of doing a test for both VLOS and BVLOS situations. And of course, you can do the testing of drones in an open category. As you know, there's an A1, A2, and A3 category. And there you can go up to 3,000 feet. If you have a drone with a takeoff mass of more than 25 kilo, or if you have a BVLOS operation, then you can either go by the predefined risk assessment, or alternatively, if needed, we can do it by an individual application to the DTCA, and that's the authorities for traffic in Denmark, with a specific operational risk assessment included. And then we can obtain the possibility of doing more tests also for drones that are perhaps fairly new, or with tools that are fairly new, where we have to be more careful. Anyway, for any type of these operations that you may require the authorization from the authorities, then the test center will, of course, offer to provide guidance and assist you with the process so you can get on with it. So what have you been doing here? I will not go into the details of all what we have been trying to do when it comes to offshore challenges, but as you can see, there's quite a number of names here that have been involved over the years. Blad Industries, Siemens, Ørsted, Vestas, ESVAG, Vattenfall, etc. And of course, several universities and many more. I just shown a few examples of some of the drone companies. So it is used for quite some different things. And just an example of something that is slightly different than what the offshore energy is about. And that's a project called Energy and Drones, the drones for energy. And that is a professor at the Southern University of Denmark who is doing a project. And what it is about is building a collaborative autonomous drone system that can inspect the power grid for the power lines and check if there's corrosion or it needs any repairs or anything. Here the drones, they can actually fly alongside the power lines, and at the same time as they do the inspection and send back the data that is needed for the data analysis, then they will also charge the battery in the electromagnetic field that is surrounded by the power line. So that's a very interesting thing, and I think you can find more of this if you want to. There's shown a link to where you can read more about drones for energy. I think that's something very interesting for many of you also. Apart from this, the inspection of power lines has, of course, been done a lot of projects, for instance, package delivery, for instance, from land to offshore. There's from package delivery from ship to offshore. And then there's inspections. Apart from this with power lines, you may know that the inspections on bridges, constructions, etc. is something that is very advanced in Denmark, and the Sun and Belt Corporation is doing that with drones these days and have a big data collection on this, so they know what to do whenever they need to do maintenance on the bridges. So this is about the quality inspection, and that's something that is very well known. And also drones to detect gas leaks and corrosion on installations in general. And then we also have a project that was only started 6 months ago or so. It's called Airspace Funen. And that's of course about making and implement the first airspace in Denmark. And it's sort of a stepwise. Right now we are preparing to test in the south region of Denmark from a small island back to the bigger island, Funen. So to get blood samples back and forth is the initial test. Later it will be medical supplies, and later again, over some years, we expect to get to the point where we can either transport the patients to the hospital or the doctor out to the small island if anything is needed. So there's a lot of things going on here, and of course this is about getting an automated authorization. It's geofencing of prioritized airspace. It's monitoring of the drones, of course, and enabling beaverless drone flights in general. And eventually it will go into an air traffic management system where we most likely will use 5G. We are testing with 5G today. And of course, the end goal for all of this, what we are talking about, is that we should enable coexistence of manned and unmanned air traffic. So that's the purpose of all this. I just told you a little bit about this project just before with the health drone. And you can read more about this. It will be included, I guess, in the power slides that are sent afterwards, where you can access it. And here you can find out more about the health drone project if you need it. I know you're not into health drone yourself, but I think you can get a lot of inspiration if you can achieve this with the health drone project in Denmark. Then there's a lot more you can achieve in the offshore industry as well, I'm sure. So that's why I included this. And I guess that's sort of the end of my presentation here. Thank you very much, Sven. Anything else? Any questions?
Yes, thank you very much, Mr. Peterson, for the presentation. Yes, there are questions. Anne wants to know, is it possible to obtain flight permits for drones with dimensions larger than 3 meters and higher than 25 kilogram takeoff weight regarding the new European regulations?
Yes, that is possible. But of course, you have to fulfill an application and send that for the authorities to get that. We have a consultant that is close to the test center who can assist on this. The test center itself cannot do this. It has to be on your drone, of course, and the things that the operation you need to perform. But it is possible, and it will take place. And we have had people flight with the drones with a weight much higher than the 25 kilos before. So it's possible to obtain it. Most likely, we will close the airspace for manned traffic during the test and will thereby be able to do it, yes.
Okay, thank you. That answers another question, because Tom wanted to know if how do you obtain authorization from the Danish authorities to perform a more complex drone test? So I guess you answered that question. Then the final question, what is the real benefit of making use of the UAS Denmark test center? So what are the USPs of the test center?
Basically, I think the best you can do here is that if you think you need to test your drone, your components in harsh environments first, that's what we heard in the first presentation, that you can do that in the lab and you can simulate different conditions on harsh conditions. But once you have performed that, before you go out and fly your operations and train directly into the North Sea offshore, then there is a possibility of testing in a little less rigid environment in the test center in Denmark, where you will be allowed to go on quite long operations overseas, but you do not necessarily have to do it in a direct environment where you're in a very busy sea and a busy offshore environment. It's an environment where it's possible to do it without too much interference with other traffic, both from air and on the sea.
Okay, thank you for your answer, Mr. Peterson, and thank you for your presentation. Before we round up this webinar, ladies and gentlemen, I would like to invite you to take a final poll. So I'm going to start the poll right now. You should be able to see it on your screen if you scroll down a little bit. Your participation is, of course, much appreciated. So the question is, which test facility would suit your needs? So for the speakers, that's some good news. Some people need more information, so you will be getting some emails shortly after. If there are any unanswered questions, it is still possible to ask them in the chat box. We will make sure every question is answered. You can also reach the experts of today by mail. So you will receive their contact details together with the replay after this webinar. So the answers are still coming in. Of course, I would like to thank you all for watching. I would like to thank all the speakers once more for their presentation, and I hope to see you once again next year. So now the poll is finished, and you will be getting an email with the replay possibilities afterwards. Thank you for watching. We will be ending this webinar now. Have a good day.